All right, let's talk about something we kind of take for granted every single day. How do we describe, well, where anything is? I don't mean just pointing and saying, it's over there. I mean with pinpoint accuracy. How does your phone know exactly where you are, right down to the meter? Well, it all comes down to this one really elegant idea that honestly changed everything. So let me ask you, straight up, where are you right now? Go ahead, think about it. You might say, I'm in my house, or you might give me your street address. But what if I told you we could describe your exact location with just two numbers? That's it, just two. That right there is the incredible power of coordinate geometry. Now, this idea of using grids, it's not new. Not at all. In fact, it's this ancient human obsession. We're talking thousands of years ago. The Sindhu-Saraswati civilization was already building their cities on these super precise north-south, east-west grids. Pretty amazing, right? Then you fast forward a bit, and thinkers like Baudayana in India are laying down even more of the geometric foundations. And then, and this is a huge piece of the puzzle, Brahmagupta comes along and formalizes zero and negative numbers, which you absolutely need for a complete system. But it wasn't until 1637 that a guy named René Descartes finally connected all the dots, officially tying together the world of shapes and the world of numbers. Okay, so that's the big, grand sweep of history. But let's bring this way, way down to something much more personal, something really human. I want you to meet Ran. Ran is visually impaired, and his family just moved into a new place. Now, for him, a new, unfamiliar room isn't just a room. It's a huge challenge, figuring out how to get around safely, confidently. It's a big deal. And this is where his sister, Shalini, comes into the picture. She has this brilliant aha moment. She realizes that the stuff she's learning in her math class, coordinate geometry, isn't just for passing a test. She can actually use it to solve a real important problem. She's going to build a mental map of the room for Rayan. All right, so how does she pull this off? Well, Shalini's first step is to do something really clever. She decides to translate the physical room into the language of math. She's basically going to turn the floor plan into what we call a Cartesian plane. So imagine her just drawing a grid right over the layout of the room. And boom! Just like that, it's not just a room anymore, it's a map. This is the fundamental trick, the core idea. You turn a real-world space into a mathematical one, where every single spot can get its own unique numerical address. Okay, so every good map needs a starting point, right? A little "you are here" star. In coordinate geometry, we call that spot the origin. It's our home base, the point 0, 0. For Rion's room, Shalini just picks a corner, the bottom left one, and says, this is it. This is our 0, 0. Everything, and I mean everything, is going to be measured from that one spot. From that origin point, we draw our first guideline. This is the x-axis. Just think of it as the horizontal line that runs along the bottom wall. It's our ruler for measuring everything left and right. Then you need your second guideline, right? That's the y-axis, and it runs straight up the wall, vertically. This is our ruler for measuring up and down, or forwards and backwards. And those two lines, the x and the y, they create the entire skeleton for our map. And now we can give an address to literally anything in that room. We call this address a coordinate pair, and it always looks like this: x, y. It's just a simple recipe. The first number, x, tells you how far to go sideways. The second number, y, tells you how far to go up. And this is where the rubber meets the road. Check out the wardrobe. Shalini can mark one corner of it, W4, and give it the coordinates 3, 2. For Rayan, that's not just a pair of numbers, it's a crystal clear instruction. From the starting corner, take 3 steps to the right, then 2 steps forward. See? No guessing, no ambiguity. It's perfect. Okay, so locating points on a map, super powerful. We've got that down. But what about finding the distance between two of those points? Especially if it's a diagonal line, not just straight across. So here's the next puzzle for Shalini. How far is it as the crow flies from the corner of the bed straight to the door? It's a diagonal path. We can't just count squares anymore. That's not going to work. We need a new tool. And wouldn't you know it, the tool we need comes from that ancient history we were just talking about. It all comes back to a timeless principle, the Baudayana-Pythagoras theorem. And here's the amazing insight. That diagonal line, that direct path across the room, it's really just the long side, the hypotenuse of a right-angled triangle. And what are the other two sides of that triangle? They're just the straight horizontal distance and the straight vertical distance. They're already there, hidden in the grid. So figuring it out is actually super simple. Step 1, you find the sideways distance. That's just the difference between the two x-coordinates. Step 2, you find the up and down distance. That's the difference between the y-coordinates. And step 3, you just plug those two numbers into the theorem. You square the horizontal bit, square the vertical bit, add them together, and that gives you the square of the distance you're looking for. And all of that simple logic gets baked into what we call the distance formula. Now, I know it can look a little intimidating with all the squares and square roots, but don't let it fool you. All it is the Bode-Pythagoras theorem dressed up in coordinate geometry language. That's it. And this little formula, it's the engine that can calculate any straight line distance between 2 points. Okay, let's zoom out again. We started this whole journey in a single room with Rian and Shalini, but the real mind-blowing power of this idea is that it can scale up to basically any size you can imagine.
Just think about this for a second. That simple XY grid Shalini used for the bedroom, it works on the exact same principle as the latitude and longitude grid we use to map the entire planet. Seriously, latitude is basically your y-coordinate and longitude is your x-coordinate. It is the same exact idea, just blown up to a global scale.
And once you realize this, you start seeing it everywhere. It's like the invisible backbone of our modern world. Your phone's GPS? That's coordinate geometry. The characters moving around in a video game, their positions are tracked by coordinates. A CT scan at the hospital? That image is built from a huge collection of coordinate points. It's in the blueprints for buildings, the charts on the news. Honestly, it is everywhere. But maybe the biggest deal, the true genius of this system, is what it did for math itself. It built a bridge between two worlds that used to be separate: geometry, the study of shapes, and algebra, the study of numbers and equations. For the very first time, you could describe a circle or a line perfectly using an equation. This was more than just a cool trick. It was a complete revolution in how we think. So I'll just leave you with this one last thought to chew on. Every map, every single coordinate system has to have a starting point, an origin, that one fixed point, the 0, 0, that everything else is measured from. So if you think about your own life, your own journey as a kind of map, what's your origin? What's your 0, 0?